Hi there, I'm Ray Anthony Rivera and I'm going to be discussing on the last two modules, modules 9 and 10. So let's start off with module 9, the transport layer of the internet. So a quick overview of transport layer. So as we learned in the previous modules, it's actually the fourth layer of the OSI model, and its function is to provide a reliable mechanism for data exchange. And it has two basic types of transport service. First one is the TCP and the second one is the UDP. So we'll be discussing on TCP first. TCP is an acronym for Transmission Control Protocol. This one is a connection-oriented transport layer protocol of the internet, and it aims to provide a reliable end-to-end byte stream between two hosts. So data segments here are broken down into segments called TCP packets. So it has the characteristics of being full duplex, so it can send and receive simultaneously, being point to point, and it doesn't preserve message boundaries. So by this, it means that data that was sent divided, for example, into four sets of bytes, can be consolidated into one large one. So for the tasks, it retransmits if there's a timeout, and it reorders datagrams in the proper sequence it should be. For the components, we have ports. Ports a logical address used for interprocess communication. So this one allows the client to pinpoint among the numerous applications running in the remote host. For the port numbers, which is present in both TCP and UDP, they're 16-bit wide, meaning they have 65,000 open ports roughly. And for the 255 below ports, they're reserved for commonly used applications. So, for example, port 23 is for Telnet. Then we have the sockets. So, the sockets are essentially what the sender and receiver need, and they're the endpoints created for them for the TCP service to take place. So, the socket address number is equal to IP address number plus application's port number. So, for the TCP segment header, the segment consists of a header followed by an optional part, then the data bytes. So there's actually three factors that restrict the segment size. First off is the max IP payload of roughly 65,000 bytes, as we mentioned. Then second one is that it must fit in the maximum transfer unit, which is roughly 1,500 bytes. And lastly, the physical layer is also a factor, such as if it's on Ethernet or tokening or whatnot. So here we have a figure of a TCP segment header. So it has the fields and definitions corresponding here. So the crucial ones being the SN, the sequence number, is assigned to a TCP packet to indicate its beginning. So if the sign bit is set, it's actually the beginning, initial sequence number. Then we have also the acknowledgement requesting for the next SN. Then we have the control bits and of course the checksum to verify the correctness. So the main functions or services it has is that it provides connection establishment, maintenance and termination, reliable packet delivery and ordering, error control, and allows multiple connections with various processes using ports. So let's break it down. And first off is the connection establishment. The application layer issues function calls to TCP like open, which is for initialization, and close for closing of the session. So the client and server perform a three-way handshake to establish the connection. So in this handshake, they actually synchronize their sequence numbers and acknowledgements. So the first step is that the SN is sent to the receiver, then the receiver sends its own SN and acknowledgement, and finally, the initial sender sends an acknowledgement, thus completing the three-way handshake and establishing connection. After that, data exchange can proceed. Then we have sequence numbers and acknowledgements. So, unlike in what we learned in the past module, sequence number is incremented by one for each byte in here. So the acknowledgement number is equal to SN plus good bytes read in the segment. This is so that each byte can be accounted for in the right order, which is what we need to make it reliable. So you just go back and for the connection termination, to achieve smooth termination, we have the fin bit in the TCP header. Now we proceed with the user datagram protocol, or UDP. So unlike TCP, this one is a connectionless transport layer protocol. So it doesn't require connection establishment before data exchange commences. For port numbers, it has the same function in TCP, but it doesn't provide SNs and acknowledgements. So packet order is not guaranteed and making it unreliable. The advantage though is that it doesn't require overhead in terms of time and bytes. So for the UDP header and UDP segment fields, here we can see that it's noticeably less than in TCP. So that justifies the less overhead. But at the same time, it means that it has less features, making it unreliable. In a real-world scenario, we can correlate TCP as being an email. So in that, it has to be reliable and the data has to be transmitted fully in order for the receiver to understand the data successfully and completely. While in UDP, we can imagine a video stream wherein it just dynamically sends out data. And for the receiver, it doesn't matter if one small byte stream is incorrect so long as the other is correct, because it can still proceed with the data reception and it's not integral for the receiver end. Now let's move on to the last module, Module 10, the application layer of the Internet. So the scope is the DNS, Telnet, World Wide Web, File Transfer, and Email. So DNS, it's an acronym for Domain Name Server, and it's essentially a substitution of the IP address using character strings. So instead of having to memorize numerics, a lot of it, we just have to take note of probably catchy domain names. In the past, Network Information Center maintained a file that contains the mappings of this, but then as the internet grew exponentially, the DNS took over and organized it in a hierarchical manner. So here's the hierarchical DNS namespace. So these are actually top-level domains, and there are two types, country and generic. They are separated by dots or periods and are case insensitive. So here is a list of the common top-level domains. So usually we see com and gov representing commercial establishments and governments respectively. We also have two entities that help in this mapping. We have the name resolver and name server. So essentially the client in the figure has to course through DNS if it needs the IP address of a particular domain name. Then once it goes to DNS, the DNS reverts back to client with the IP address, and then client uses this IP address to route to the server. Now we move on to Telnet, which is a TCP IP app that performs remote terminal services. So this one similarly requires a DNS service unless the IP address is directly provided. So the negotiation between the host and remote terminal here is denoted by the will or do statements. So will actually implies that the client side has the capability, such as for echoing, if it has the capability, it will just mention will. And the vice versa is if it doesn't have the capability, it will request the server to do so, which is the do statement. Now let's proceed with the World Wide Web. So this one's a framework for accessing distributed documents on the internet. So initially it started as a small hypertext system used to track shared projects across different landscapes. And then it consists of documents called pages. And in these pages there are links, which are portions of a page that direct to another page. Then we have the browser, which is what fetches the page requested and then applies formatting specified by the HTML document to be discussed later. Then we have HTTP server, which is Hypertext Transfer Protocol. This one listens to TCP port 80 for connection requests from clients. So, to explain further, we have the client requesting to have access to a certain website. It goes through the DNS, and then the mapping provides the IP address. And then once the client has the IP address, it goes to the server and requests for the server for the data. the server then reverts the data to the client. Here we have the defined HTTP request methods. And then we finally proceed to Uniform Resource Locator, or URL. So this one is the one we always see at the top of web browsers. It's the address to a resource on the internet, and it allows user to navigate the web and a lot of other features. Altogether, in an application, this is essentially what a web browser is. So the URL actually answers the three questions: what's its name, where's it located, and how is it accessed via the protocol name, domain name, and client file name. For the various protocol names, here we have it listed. So let's go now to the HTML, the Hypertext Markup Language. So this is a language used to describe how a page should be formatted when displayed. So it contains explicit formatting commands called the tags and is managed by the World Wide Web Consortium. So it's actually not a programming language, and for the taggings, we can actually see this in every web page if we right click and click view source. So there we can see how text is formatted. So I stand for the italics, B for the bolds, and etc. Now we have FTP. So FTP is on File Transfer Protocol. It allows files to be transferred across a network reliably. So it uses two ports. That's port 20 for control connection and port 21 for the data passing. Port 20 is retained once the connection is established, while port 21 automatically closes once data transmission completes. Here are the commonly used FTP commands. Finally, we have email, electronic mail. So this is a system where the computer can exchange messages with another one. So it's the most popular application of the internet. And the source machine transfers the message in the destination machine's TCP port 25. It has two subsystems, the user agent, mostly used for the user for reading, and then the message transfer agent, which is more on the system, which because it accounts for the message from sender to destination. This is managed by the system daemons, which are background running programs which require minimal or no human intervention. So we have 5 basic operations in the email system. Composition, which is the creation of the email. Transfer is the sending. Reporting is the status. Displaying is the viewing. Disposition is the post-processing in a way. It's the saving and forwarding, etc. And we also have two parts of an email. That's the header and the body. So the body is the one crucial to the user. We have two popular email standards, and we'll be tackling more on RFC 822, which is the one for internet. So here's its email headers. So this is going to be familiar to anyone who has experience in email. So we have the two CC. CC stands for carbon copy, while BCC is blind carbon copy. So the difference is that those in the BCC field are not visible to the rest of the recipients. For the protocols involved, we have SMTP, POP3, and IMAP. So SMTP is the one that manages the sending once the connection is established to the mail server. And then POP3, 3 indicates the version, is the one that manages the fetching of the mail from the mail server. And then the IMAP is an interactive map access protocol which manages a central repository accessible from other machines. So usually companies have this to manage all their emails. So to simplify it, you can consider SMTP as being on the sender to mail server line, while the POP3 is on the receiver mail server end. So that concludes my presentation. Thank you for your time.